Hello, everyone. Thank you for tuning in. You should be seeing this hopefully now on YouTube and on Twitch. This is a series, one of the interviews in a series of videos interviewing the creators of programming languages as part of Exercisms 12 and 23. And I'm excited and really privileged today to be joined by Bjarne Stroustrup, who is the creator of C++, as well as the author of numerous books and publications. Dr. Stroustrup has a fascinating career, including working at the legendary Bell Labs, and is now a professor at Columbia University in New York City. Thank you so much for taking the time to join us. How are you today?
Sure, I'm doing fine,
Good. We were just talking before we started, and I was asking if you had any time to write any code yet today, and you said not yet, but maybe this afternoon.
Yeah, something like that, yes. It's probably write some code most days.
Nice. You're a fortunate man. I think a lot of developers end up sort of, as their career goes on, being able to write less and less code. So I always think it's nice if you can hold on to that core skill. So for everyone watching, this session is going to be split into two parts. The first is a sort of interview style conversation. We're going to be exploring the journey of building C++, especially around some of the big decisions that were made and what that journey was like. And then we're going to be opening the floor up to your questions. Lots of people have already sent questions in. If you have questions, please post them in the comments on YouTube, on Twitch. Eric, Aaron, and Jonathan are monitoring those things, and Discord as well, and will pass those questions to me, and then I'll ask them a little later. So let's get started. So the first thing I'd love to just explore is the motivation behind creating C++. In speaking to people so far, it seems like the motivation is often around a sort of dissatisfaction with either the existing programming languages or something missing, maybe a specific thing that you wanted to be able to do that things at the time couldn't do. And I believe you're at Bell Labs at the time as well, which must have been a fascinating place to do. What was that original journey like in creating C++ and starting that?
Well, when getting this question, I remember Dennis Ritchie, who did C, making a point that some languages are designed to solve a problem, and some languages are designed to make a point. And I think Dennis's point was that most languages come in the second category, and C, and in my case, C++ comes in the first. Mm-hmm. I had gotten this idea back in 1979 to build a distributed Unix system. So if I'd actually done it, we would have had the first Unix cluster back in the early to mid-80s. Obviously, I couldn't do that. I didn't have the skills or the time or the resources. But early on, I realized that looking at the code, I needed two things. One, I needed to fiddle with the hardware and build things like process schedulers and memory managers. And then I needed to abstract from that. I needed to be able to say this piece of code runs here and this piece of code runs over here, and they talk through a communication channel using some protocol and such. And that's not low-level stuff. And if it's a distributed system, you can't just have pointers floating all over the place pointing to things, because the things may be on a different computer and such. So I concluded that to build this system, I needed a language that could do low-level stuff really well and do high-level abstraction and information hiding really well. And looking around the world then, there just wasn't a language that could do both. And well, then I thought that if I wanted to do my project, I had to get such a tool or language. I thought about it as a tool for a while. And then I realized I was designing a language. Actually, I was being a bit slow, so it took me a little time before I realized that. And some of the really early things reflects that decision, the emphasis on being able to manipulate hardware and do so efficiently, because I'm talking about an operating system here, and device drivers, process schedulers, that kind of stuff, where performance and in time and speed is essential. And then the abstraction has to actually not take away that performance. You can't just go high level and throw away all of the machine, not if you're in this domain. And so out came the zero overhead principle. And I had some notes. The idea of constructor destructors for classes came very early on, like week 2 or 3, something like that. That's the real start of it. I built the low-level stuff on C, of course. It wasn't a bad choice, and it was a reasonably obvious choice with Dennis Ritchie and Brian Kernighan down the corridor. Best support that anybody ever had. And for the high-level stuff, I've been working with Simula for a while. That's the source of the object-oriented stuff, the classes, the class hierarchies, and also for coroutines, which I needed badly for that what I wanted to do. So that was the origin. And then it turned out that I had one more idea that became important. That is, I did not want to solve a particular problem. I wanted to build a tool for solving a class of problems. And so instead of building a distributed system tool, I built a language that could express a large class of problems that has this characteristics of abstraction is needed and performance and hardware access is needed. And that turned out to be a very large domain. And very soon my friends started trying out civil classes, it was called. And they liked it enough so that I got users, and so I ended up having to support the users. I mean, what else can you do when your friends and colleagues are using something you built? And I actually had a real genuine user that wasn't doing research but was building things 6 months after I started. And so I haven't really had a free choice for what I'm doing since, because once you've got users, you have an obligation to provide stability and support.
Yeah. What point did you sort of did you think, wow, this is not just like a toy hobby project now. This is something you probably didn't think this is something that's going to dominate the next, I don't know, 40 years of my career. But what was that like emotional journey like? When did you realize that this was going to be a legacy?
It took me some time to realize, partly because it was never a hobby. It was meant to be a tool for me to use, and then it became a tool for other people to use. And to be honest, the 1980s for me was a bit of a blur, because there was so much going on. I mean, I was the designer, I was the implementer, I was the teacher, I was the author, I was the help desk. The whole, absolutely the whole stretch of support for a language and its users. And so I didn't get too much time to sit around and thinking, is this great or isn't it? No, is it useful for my friends and colleagues, or isn't it? And if it isn't, I either have to give up or I have to make it better. At some point, like in 83, I realized that civil classes just wasn't good enough. It was a medium success. Lots of people using it. I mean, maybe 500 people. And I realized that it would be the rest of my career supporting this if I had to be the teaching, training, maintenance, supporting person. So I thought I can either drop this or I can make it better. And if I dropped this, I would sort of go back on implied promises to maybe 500 people. So I thought, I'll have to make it better. I have to make it so good that it'll make so many users that somebody else can maintain it. And I guesstimated that if I got 5,000 users, everything would be fine. That was my great ambition back in early 83. And so I revised it to be C++, which was the only sort of major incompatibility I introduced. And that was only by changing a few names so that you could re-edit your programs. The model with constructors, destructors, and such was there. Well, it worked. And then you can see the growth curves for C++ in about late 79. There was one user, then two, and the doubling rate till about 91 was every 7.5 months, which is quite extraordinary. And in the early years, it was just all me, and then later it was a few colleagues of mine that was helping, and we never had a budget, really. Certainly.
It was interesting. I chatted a couple of weeks ago to Cameron, who's the product lead at the Go team, and we spent a lot of a language having a product team tells you a lot in the first place, but it was really interesting how much Google invest in Go and how it's a big part of their commercial strategy. And not only do they have marketing budgets and things, but they've got huge teams behind Go, and that popularity then you can look at and you can see Go's growth. But what was that marketing growth like for you? How were people discovering C++ back in the day when you didn't have that budget? You weren't a marketing person. What did that look like?
Pretty strange. This was some papers I wrote and some talks I gave. I always used to go to conferences or visit places, mostly to learn things, but also to try out my ideas. AT&T did, in sort of the late 80s, give me a marketing budget. They gave me $5,000 to spend over 3 years. And by the time I heard of that, they'd already wasted 1,000. And I looked at this and says, what can you do with a marketing budget like that for a general purpose programming language? And somebody had started a C++ workshop, which had a couple of hundred people turn up. And so I thought, I'll throw a party. And that's what I used the budget for. Couldn't even spend the whole thing. When I went to the first, or was it the second, OOPSLA, we were going to have a booth for C++. And, well, with no budget, that was a little bit difficult. Like, we couldn't have a computer because we couldn't afford to bring one, and this was before laptops. And we didn't have any sort of fancy decorations. What we did was we borrowed a blackboard, and I had a sign-up sheet for some of my papers.
Right.
And then we took turns to stand by the blackboard and discuss things with people who are interested in discussing things.
Nice. At what point do you feel like it moved more out of this sort of research academic community into the mainstream community? You mentioned you had this one person early on who was using it in the real world, but was that sort of early 80s as well, or did that come later? Or?
I don't remember the exact numbers. You can look it up. I wrote a paper for the History of Programming Languages conference. Actually, I wrote 3 papers. And if you look at the first one, there's the growth curve. So you can see the estimate of how many users there were at any given time. And in the late 80s, we're talking about in the hundreds of thousands, I think.
Wow. Okay.
And this was still just me and a couple of friends.
Yeah.
In the late 80s, several organizations, several companies started to decide they could do better than my compiler, which translated into C so that I could use the C code generators and get easy portability. And they thought if they wrote a native compiler, they would get better code faster. Well, it took them years to catch up with the code quality, and but that meant that you have organizations like IBM and Borland and later Microsoft building compilers for it, and they of course had marketing to their customers and such, but I had nothing to do with that. I just getting things standardized because it was clear that we could get major compatibility problems with these major organizations building new things, and that was actually forced upon me by IBM, Sun, and HP. They turned up in my office, 3 people, and said, you want to standardize C++ under ISO rules. And of course I said, what? And when they explained to me what that was, they said, but it's too early. I'm still working on it. I'm not finished. And they said, you don't quite understand it. Our organizations cannot depend on a language owned by a different company. We will, of course, trust you, but we can't trust AT&T. So we need to set this up. And so after an hour's worth of arm twisting, I said, sure, yes, I really want to help standardize C++ and rules.
Somebody asks in the questions what kind of madness you need to build a new language and have the motivation to finish it. Do you feel like there was somebody else asked maybe a tangential but related thing about Smalltalk at the time, and they asked if you had seen Smalltalk, and I've read before that you sort of see Smalltalk as a sibling. How much in this time was it quite a fertile ground for creating new languages? I know I always think of the early 90s as when a lot of the sort of modern languages really got created, and obviously this came before that, but was this quite a unique thing to be doing at a time? Was it a madness, if you like, that you wanted to do it, or how do you see it?
No, I had a problem. I was into machine architecture and architectures to provide high-level support for operating system concepts. Great fan of hardware protection of memory and such. Worked on the Cambridge CAP computer with capabilities. And my field was distributed systems. So I wanted to build a distributed system. I mean, that's what people doing research in distributed systems do. Yeah. And when I realized I couldn't do it effectively with the languages in existence, I felt I had to build one. It's sort of not any really deep thought in terms of languages. It was just I needed that one. And then it turned out to be very useful for a lot of people.
So digging into
I knew Smalltalk not very well, and its domain, what it wanted to do was not what I wanted to do. I mean, you don't really write device drivers in Smalltalk. They were very keen on making it very easy to a lot of people to use, very smooth, totally flexible and such. And today, the successor for that kind of thinking is probably Python, which is not what I want to do anyway. If you write raw Python, it runs 70 times slower than C++, which is why they use C++ libraries when they want performance. And from the early days, I was not trying to build a language to take over the world. It was one language among several. I was exchanging code, have programs written with code that was partly assembler, partly C, partly Fortran. And then you put it together with shell script in Unix. It was not it was a tool among many.
Yeah. So going back to the standards that you were talking about a minute ago. So in this series of interviews, it's been really interesting because I feel like we've spoken to people at different points along this journey. So, we spoke to Jose, who created Elixir, which is pretty fast growing language. But it's still very much his sets of decisions as to what goes in it. He has the final say. We've spoke to Josh from the Rust team, and they've just recently gone through a whole process of restructuring, putting governance and all of this sort of thing into try and, I guess, turn Rust into more of an organization. With Go, we see the control Google has, and you've gone down this other route, this ISO standards route. How do you feel the ISO standards have affected the development of C++? I don't necessarily want to ask you if you think it's been a positive thing, but what have the trade-offs been in that? Has it shaped the language a lot more? Has it sped it up, slowed it down? How do you think that's affected it?
It's really hard to summarize because, well, we're talking about 30 years and lots of people and lots of individual things. First of all, I didn't really have a choice. When the three largest manufacturers of computers at the time comes and tells you that this is the only way, well, I was just a researcher, developer. I couldn't argue with them. They could have gone over my head and gone to my employer, and they would have gotten their way. My idea for a language is more like a small sort of secretariat that gives direction, does experiments, make final decisions from input from a larger community, which is not what ISO does. ISO says if you pay, I think it's $2,000 a year and turn up, you have a vote, one person, one vote. And we have, well, 250, 300 people turning up. This is not easy, but it does give a lot of energy and a lot of input. But the point is that the secretariat model, and really any other model that sort of is real governance and control by a small group of people, cost money. And I didn't have any money. I looked into it a couple of times over the years. Could we create something like that? And I soon found out this was not in my skill set. Somebody might have been able to do it, but I couldn't figure it out. I always got distracted and wrote some code or designed a facility or something like that, where I probably should have been focusing more on governance and money, but no, it didn't happen. Sometimes let's say it this way. You can move fast if you have a dozen or a few thousand users. You can't move fast we probably got about 6-7 million developers. You don't move fast. You can move fast and break things, but not when there's billions of lines of code that they don't want broken. So yes, I'm very frustrated when things aren't moving fast enough, and I'm frustrated when somebody in the committee just can't see the light as I think it is. But on the other hand, there's a lot of people there. They have ideas, they make contributions, they design things, and sometimes they're just right.
Yeah.
And so it's a very difficult situation, but it's not one you can change. One of the fundamental things is people and groups do not give up power. Committees don't close down. People don't say, well, I can vote on this, but let's make a governance change so that all the votes are of these 5 people in the corner. It's just not going to happen.
Yeah. Somebody asks why there's ISO standards for the language, but not standardization in the way C++ is written or C++ code. And I guess this comes down to you wanting it to be general purpose, something that people can use how they want. But where do you draw that line, I guess?
Well, it's hard to say. There are languages that are designed so that you can only do what the designer wants you to do. Some of the Viet languages are designed like that. I looked at that a long, long time ago and decided that I did not want to have a language that could only do what I could imagine. And I did not want a language that could only do what I thought was right, because I didn't trust myself that much to it. And I knew very well that in a larger group of people, there are more ideas, including good ideas, than I could possibly have. So that was deliberate. And I then decided to go with sort of the education way. I talk and I write and I try and explain to people how to do things right. And sometimes it works, and well, a lot of times it doesn't. I was complaining back in the 90s that we couldn't teach teachers fast enough, and then you come people in with ideas that are alien to me, but they push them as the one true way. I mean, we want things to be totally purely object oriented. Everything should be class hierarchies. Everything should be virtual functions. Shouldn't have overloading or things like that came out of academic ideas. And I had very carefully designed the language not to follow those rules, because I thought there was need for the facilities there were. And to this day, there are people that are pushing philosophies and complaining that C++ doesn't meet their exact philosophy. Well, you know, if this has been a dictatorial language, it would not have followed their theories. They would have followed mine, and they wouldn't have liked it. As it is, the fair looseness and openness of the way I design means that they can actually do what they want to get done, complaining bitterly that it isn't perfect for it. But you know, if you get 10 people or 1,000,000 people, they are not all agreeing on what is the right way. And so you have to give and take a bit.
Yeah. I mean, I haven't used C++. I was trying to work this out last night. I think it's 25 years since I learnt C++. It was the second language I learned. And I was looking yesterday in preparation for this, and I was impressed at how alive, like, the development of the language is. Like, there's so much new things going in. It feels, I know there's lots of questions already about what do you think about this in this language and this in this language, but it feels like very alive and actively developed still. How do you see C++'s place in the world today? Like, is it a language that you still feel is like an ever-growing new fresh language? Do you imagine over the next 40 years it will continue to be growing in that way? How does that sit with you?
It's hard to say. Currently it's growing, and it's growing faster than most other languages, and it's growing faster than just about all the wannabe competitor languages put together. We seem to be putting on 100,000, 150,000 new developers every year. I don't know how that happens. It's even hard to count. But the people that do surveys in industry and such comes up with numbers like that. I used to say 5 million. Now I'm being told off for I shouldn't be rude to C++ by underestimating the number of users. I'm always slightly underestimating the number of users. So maybe we should only say 6 million, but I would be told off for that.
Yeah.
By people who has better numbers than me. Actually, if you go back to my first Hubble paper, there is a graph, and I had numbers because I was talking to everybody. I knew who was writing compilers. They told me how many users they had. I talked to the publishers. I knew how many publications, the books they were selling and things like that. So those numbers are reasonably solid.
Yeah.
I don't personally have as good a hold over the number of users and how they use it as I used to be used to. But then the community is, well, 40 times larger.
So is the development of C++ driven by the needs of that community? Are they requesting, can you add this to the language, and then it goes through, or is it driven more by you or other key people who are deciding what's going into it?
It seems there's a lot of people who want to design language and language features. And as I said, as Dennis said, somebody is motivated by making a point. They've got learned something in school and it has to be in the language, or somebody has a real problem. And I try very hard to understand what is the real problems and not get overly influenced by fads and fashions. I always get beaten up for that because you're supposed to follow fashion. If everybody agrees it's like this, it must be like this. No, not necessarily. For starters, most of the people who really build things don't actually go out and talk about them all the time. They're too busy building it. I mean, as I say, he who rows the boat too busy to rock it. And so for all of my years as a professional, I've been traveling around maybe 5-6 times a year, going to places where people were doing interesting things with C++ and listening to them, trying to explain my new ideas, see how they responded to them, listening to what they said the problems were, and then going home and thinking about it. And so I've been to people building cars and aeroplanes, and I've been to finance places, games places, just lots of places. I was really feeling bad over COVID because I couldn't get to talk to people and I was deprived of input, and I felt you can't do language design well if you're flying blind.
Yeah.
You really have to talk to people, and it's not just language geeks and academics or people in the most advanced computing establishments. Most people are not in the most advanced places, and they sometimes have perfectly good reasons for not being there, and the needs of a Google may not be the needs of a small shop doing something, games, finance, or payroll. I don't. Certainly, I found that a lot of designers forget that the average education level of a developer is not a PhD, and they don't, by and large, care about programming languages except when it gets in their way. And they don't want to go away and learn type theory for a year or so. So you have to listen to them and you have to get through to them.
It's very,
for a new language, just about everybody are advanced and they have the best information, the best support. And as the user group increases, the quality of developers goes towards average in the world we're in. So, I mean, people tend to forget that about only half the people are above average.
That's a really interesting insight. I'd never considered that about the trend of a language over time. I think that phrase, everyone at the beginning knows everything about the language is really true. What do you might not have an answer, but what sense do you have as to the direction of programming languages? So there's you talked almost like 40 years ago, you were interested in distributed systems. I feel like distributed systems are now more relevant than ever. There's obviously things like the rise of AI and everything around that, things like VR. Do you have a sense of how programming languages, how C++ will adapt or might need to adapt to those things?
That's a very hard question. I think there's a mistake that almost everybody seems to be doing, which is to think that programming development is one thing. the people who write code for a power supply, the kind of things that sits under your desk and feeds your laptop, is not the same as the people who write a web app. Very different thing. The people who do the controls of an aeroplane or a car are very different breed for people who, I mean, anyway, so the point is there are lots of different domains and they require different skills. And one of the things I am sad about is that a lot of educators are galloping towards making things easy with the idea that everybody should program. You know, I don't want everybody to write the controls for my brakes in my car if I had one. There are so many things that requires actually real engineering, not just people with engineer in the title. Amazing concerns about reliability, maintainability, and things like that. And if it was up to me, the education in software would break into at least two. Namely the engineering, low level, foundational, infrastructure level, and then the application level. And the dividing line might very well be what could crash a system and what couldn't. C++ is very big in the sort of the low-level foundational stuff. It's not all low-level, but it's foundational. And so everybody has been sort of basically using C++ today. They've been driving a car, they've been using a telephone, they've been watching a television or something like that. Okay, they've used it indirectly. And that kind of applications is what I'm interested in. So if you look at something like AI, which people do all the time now with these new AIs, and they tend to be programmed in something like Python. But Python runs a TensorFlow, and all of them run something like TensorFlow, and that's C++. It's something that has to run really fast and reach a certain abstraction level. It actually sort of, by accident, fell into my original category, even though my knowledge of AI is very limited.
What about the other side of AI? Someone asks, from it being a tool that you as a developer could use to help you in programming. Have you experimented with like the GitHub Copilot stuff or like ChatGPT, or do you have a sense of that? Are you a skeptic or are you a believer?
I've tried ChatGPT, but I wasn't too impressed. It can express things. I have not used it for code. It seems to be very good at writing code that was written before. That is, it goes out and it scavenges the web and it finds solutions to the problem you asked about, and you know some of the solutions are good. I hear from people who know more than me about this that actually the quality of the solutions that come up are not necessarily improving, because now all the students are dumping their homework on GitHub, and the AIs find it, and so they find all the bad solutions also. And since they are basically voting mechanisms, what most people say is right. It's like a TV show where the right answer was not the correct answer; it was the answer that everybody else had, and that's sort of the way they work. Which means that if you can train it on enough good stuff and not get the bad stuff in, it will be brilliant. But every time people have tried, it soaks up bad stuff. This is why you've had AIs turning into Nazis in 3 days, because they speak louder. And so also there's some academic stuff for copilots that says that actually there's more security violations in stuff where people have co-pilots than people that aren't, because people are not paying as much attention to the stuff they get from their helper. And the helper gets things from averages, and it has the average bug rate. Time will show whether this is going to be true in a couple of years. I don't know. As I said, I'm not the expert in this. But I am currently less impressed, and since I'm very interested in the sort of the safety aspect, the maintenance aspects of things, that's where my interests are.
Yeah. So having ChatGPT write the software for your brake pedal is something that is terrifying, but it might be a little bit better if it's just designing something at a lot high level.
I mean, if it was doing a website for selling socks, I wouldn't worry too much.
Yeah, it makes sense. I think it's really valuable, my take at the moment, as a productivity tool, if it can help you be more productive. But it's like you say, it's something that you don't want to be relying on. You don't want to just be taking what you're given and trust that it's going to be good.
I do expect and slightly fear that when I want to buy socks, it'll be AIs that will choosing which kind of socks I can watch on the screen. But better than the bricks.
Better than the bricks, yeah. There's a lot of questions coming in about people wanting to learn C++. Some were sent in before. One person was saying that there's just so many ways to learn. They said they learned 20 years ago from the C++ programming language and from Scott Meyer's books, and now you've got video tutorials, Q&A websites, Stack Overflow. You've got things like Exercism. One of the questions is how do you recommend people learn, and specifically how do you recommend people are learning, I guess, the modern C++ way, rather than getting caught up in, I don't want to say legacy code because there's maybe judgment in there, but the latest standards rather than the old standards, if you like.
Yes, that has, by the way, always been a problem. From day one, I had the problem where people would encapsulate their stuff using constructors, destructors, private data, and such, instead of just doing old C-style code and having all the old C-style bugs, and that's still a problem. So I've been writing and talking about it. Before getting to my answer, I'll also point out that one of the problems is that a lot of the stuff you find on the web are people wanting to show off. There is a style of presentation which I thoroughly loathe. It's basically look at this, look at this. It's complicated. It's very advanced. I understand it. You don't. So I'm much smarter than you are. So pay me. That kind of style of presentation, I would like to see not existing, but there's a lot of it out there, and some of them are louder and more smooth because they have a product. It may just be themselves, but they have a product they're selling. So I'm a bit old-fashioned in the way I write. You are supposed to read and try things out. Just a second.
Of course.
Okay, different people have different needs. So there is beginners and there are experienced people. And I do have what I think is a pretty good answer to people who are already programmers, who's already developers and want to brush up on what C++ is or look at it for the first time. Of course, I'm sitting in a place with a lot of books. Some of them are mine, but this basically is the answer.
That's it.
Tour of C++, third edition. It's been out for about half a year. It does cover a fair bit of C++ 20 and a little bit of C++ 23, actually. Right. It's not a thick book. I wanted it to be 256 pages, which seems a nice target. And if you exclude the index and the history section, it's there, but
Nice.
it is a few more, 300 pages or so. And about the history section, I really think people ought to know a bit about the history of things, because that's one of the that allows people to understand why things are there and such. When I teach, I always go on about why. There's so much teaching out there that just how to do this, how to do that. People don't get the intellectual framework that allows them to understand things they haven't been specifically taught. And I would like people to understand things so that they can attack new problems that the teacher hadn't imagined. And so that's the answer. If you're already a programmer, try a tour of C++. Get the third edition. One of the amusing things is that Amazon is trying to sell off the second edition, even though they still have the price higher than the third edition. The world is strange. Maybe an AI chose that. Now, starting from the beginning, I think you can probably use a variety of languages. I actually did teach a course for freshmen, university things, and I wrote a book for this. And if you are starting from scratch, this is the one.
Okay.
That one's lying there because I'm actually trying to revise it and make it half the size. But again, back to this idea that programming is many things, and I don't think you need the same thing for everybody. Also, the novices get thoroughly confused by the video stuff, and if they stuck to the books and the teaching for a little while before they try to be advanced, that would be good. Once you have some experience, once you have tried some things, you can filter out the hype. It's very hard to distinguish between hype and nonsense and solid stuff if you are not already an experienced developer.
For anyone watching this as well that's not familiar, if you want Exercism, you can get your solution mentored by more experienced developers for free, or more experienced C++ developers. So when you submit any of the exercises, you can just request code review, and somebody else will do that for free. So that's another useful way. Once you've learned C++, someone points out that there doesn't seem to be any sort of official certification for C++. Is that something that you wish there was, that you thought would be a useful, valuable thing? Are there any certifications that you would recommend people got?
Okay, couple of things here. First, showing those books was not an advertising trick.
No.
To lie on my work desk because I get questions related to them, and I'm actually working on that Swan book. The other thing is that I've been trying to work for years, worked on a set of rules for good modern C++. It's called the C++ Core Guidelines, which is a joint project with several people, and you can find them on GitHub. So if you search for C++ Core Guidelines, you can find some advice there. And it's part of teaching, and there's some books about it and such. And that's an attempt to help people get on board with modern stuff. I think I forgot part of what you asked.
Certification. Are there any certifications?
I don't know about it, and I don't actually know who I would trust with certification. Quite a lot of certification I've seen has been designed to be easy to evaluate and also be quite backward looking. One of the problems is when there's so much code out there, a lot of people want to know how that was written and write it in just the same way. And it's very easy to get stuck in 20-year-old style.
Mm-hmm.
And I try not to do that. And I do not know what the aims and background of a certification business would be. I just don't know.
Makes sense. So maybe on to some more technical questions that people have asked. So one question is saying there's a lot of features in some of the newer programming languages that have got love and attention. They give 3 examples, which are Go's built-in Go routines, Rust biochecker, NIM's compile time macros that modify the AST. Do you think any of those will be coming to the C++ world? Do you generally go and look at other languages and see what they're doing? Is that part of your process?
I look at other languages. C++ was born with coroutines, but put in a library because I didn't want to load the language up with everything. And with C++20, we have rather nice coroutines, and they lack a little bit of library support, but that's coming. It's not a copy of Go routines. It's not inspired by Go routines. I have been trying to talk the C++ community into getting Go routines back. I lost them when Sun started shipping C++ without that part of the pre-standard library that I was always shipping. And I missed it ever since. Now they're there. And if you look at it, we don't have modern macros. We do have a lot of stuff for doing compile time computation. Const expr functions that can be just ordinary functions that compute at compile time. We have templates for template metaprogramming and also just for generic programming. And with concepts in place, it's now type safe, and you can overload on templates and things like that. So it has very broad facilities for compile time computation. And that again has been an aim since a long time ago. The Design Evolution of C++, the book I wrote to describe C++, and came out in 1994. The section on templates starts out with a 3-page apology for not being able to type check templates up front at the call point. We now know how to do that, and it's shipping as part of C++20. Nice. Everybody has it. And of course, the books I was pointing to describes how to use it and what the tools are. It's standard. It's meaning ISO standard. So yeah, it's growing. Some people complain that the language isn't stuck in the past. They don't want it to change. They don't want it to grow. And well, then you would be stuck in the past. And then there's people that says, why aren't you breaking everything? Just break that. You don't want that old stuff. You know better than some of that old style code. You can do better. Yeah, you can. But you have to teach people to do it. And also, people don't want their code broken. So my solution to this is that you don't break old code. You don't throw away facilities in the language, because somebody's going to use it. Have been using it. There will be millions or billions of lines of code that depends on it. If it isn't, it's so trivial that it doesn't matter whether it's there or not. And so, but you can change use. This is why I'm working on guidelines, that's working on education. But you need not just telling people what to do, because people don't particularly like being told what to do. You have to provide some support for it. And the idea with the core guidelines is that there's a set of rules, and they work within a framework, which is basically the ideals for the language. And then you can build checkers that checks whether you are following the rules. And if you are not, my ideal is that up pops a little little message that tells you which rule you broke and how and why that rule makes sense and what you can do instead. That's where I want to go. So maintain fairly strict compatibility of the language, but move the use of the language forward.
That makes sense. And there's a big shift in that. I think, in other languages like Go again is so standardized in how it's used, and linting and things have become such a big part of a lot of modern languages. Setting those sorts of, they're not standards in the language necessarily, although Go I think is quite strict, but they're code bases that have these standards.
Technically, they don't have a standard, but also they have an owner. So they have finances, which is good, and they usually have a single tool chain, which also simplifies things. And the real definition of the language is what the tools are doing. And if they change, well, then the language has changed. We'll see what their policy is for consistency and coherence over the years are when they get old enough. With C++, we don't have a monoculture, which it can be a nuisance, but also is a strength. If some organization decides they don't like C++, there's another one that picks it up. If there's one organization that wants to have it done exactly their way, well, you don't have to follow that organization. I like cultures that has some variety in them and has different supports. So the C++, we have maybe 4 major compilers, so it's pretty safe.
Somebody points out that if you had 1 cent for every line of C++ code that was out there in the wild, you'd be the richest man in the world by far. Somebody asked if there's any plans to put pattern matching in C++?
Yes, I've been trying to do it for a while. I think we might have had it if it hadn't been for COVID. COVID really disrupted the work on the standard. On a Zoom or equivalent, you can have a good meeting if you have a well-defined topic, an agenda, and you can stick to it. It's not good for design decisions. Certainly my favorite design tool is a blackboard or a whiteboard, and a group of experienced people talking for a couple of days. We haven't been able to do that. There is a design. The problem is with the C++ standard, of course, there's 2 designs for pattern matching, and we have to decide how to do it. But this is something I've been pushing for a while. It makes code more elegant, and it closes some type safety loopholes, always increasing the ability to write type safe code, resource safe code. That was one of the original aims of C++, and it's coming slowly, far too slowly for my taste, but probably too fast for a lot of people who like to do things the old way. People who like the old ways, if they can do things the way they did it last year, then they don't have to think. And there are people who claim, I think correctly, that there's few activities as unpleasant as thinking, for real thinking, as opposed to just cranking out known answers.
Somebody else on the other end of the scale maybe asks, they say there's built-in operators in C++ for things like new and delete for dynamic memory. Will there be more built-in stuff for common low-level operations? So they give examples for things like memcopy, memcomp, built-in common types like size T or initialize a list, maybe something around parallel execution.
By and large, we try and go with libraries and intrinsics. And That means that what comes in can get very low level and almost useless until you get a library surface over it. There is work on the lower levels of the language. I can think about character sets and concurrency issues. If you look at the C++ 11 standardization of the memory model and such, I mean, you can write things in relaxed memory models in C++ with a well-defined semantics and good support across different hardwares. A lot of people are not aware of that. It's actually quite funny because at the time we knew we needed to formalize the use of concurrency in memory. And so we thought Java has done a lot of work on this, so let's borrow their model and not start from scratch. And that instantly got vetoed by IBM and I think it was Intel. And the reason given was that if we have to follow the Java memory model, our Java implementations will slow down by maybe 2.5 times. So you can't do that. You have to do something that is more efficient. And so we had to go away, and it took about 2 years or more. And we came up with something that was efficient enough on the variety of hardwares that these people cared about, that anybody cared about in the committee. And it's, of course, very much more complicated than the Java version. And now, of course, to save Java, we have now become the target of criticism for being slow and complicated. But you can't respectably and professionally just try and cripple another language. It's just not done. And so we did the work, and it worked, and it was good, and well, the Java guys are happy. At least the ones that know what's going on in the low levels of JVM.
Somebody asked, what's the tool chain that you use on a daily basis?
Depends. When I'm just sitting at home or when I'm traveling, then I'm using mostly Visual Studio and some Microsoft stuff. The Microsoft C++ compiler is probably the most standard conforming just now. And then I have Clang and GCC sitting on my machine. I don't work in industry just now for the first time in my life, roughly. But before I retired from there and became a professor instead by more or less accident. Then I was using mostly GCC on Intel hardware and massive systems there and a little bit of cloud stuff. But now we're talking about server farms.
Yeah, big things.
But I'm not doing that every day just now.
Okay. So
I used to insist that I had to use at least 2 tool chains or at least 2 compilers or editors and such to have any clue about what other people were doing and to not get stuck in thinking that there's just one way of doing it.
So to get you to put your professor hat on for a moment, so there's a lot of C++ developers watching this, but there's a lot of other developers who aren't C++ developers and maybe developers that haven't done much with lower level things. And one of the big questions I'm sure you get asked all the time is around things like pointers and how to use them correctly. Do you have any axioms that to be followed, or any principles or any guidance that people who are new to pointers and new to maybe memory management in general could use?
If you are not interested in low level stuff, you don't need to do that. You just stay away from them. They belong mostly in the guts of the implementations of abstractions. Don't use C-style strings when you don't have to. Use a C++ style string. They have copy semantics, and such. If you have to point to something, like if you have a class hierarchy and you want to point to the base class, use a smart pointer, a unique pointer, which points to one thing, and once the pointer is deleted, it deletes its object, so you don't have memory leaks. If you have shared things, so you don't know who owns it, use a shared pointer, which destroys the object when the last user goes away. It's all based on the RAII model, the constructor-destructor model. So if you deal with resources, have a handle on them. And if you want to be concrete about that, I can recommend the tour that explains it from an educational point of view, and you can look at the core guidelines that sets a series of concrete recommendations about how to do things.
Thank you. I'm aware that we're taking up a lot of your time, so I'm just going to ask a couple more questions. The first, and lots of people have been asking this, is, are there any bits of C++ that you feel particularly proud of? It might be things that maybe you introduced early on, or advances recently, but anything you're particularly proud of?
Constructors, destructors, surprisingly enough, were new at the time. People could have initialization helps built in, like Simula did, but having two different ones, like overloaded, was not there. And destructors, seems nobody had them. They built garbage collectors instead, and then they pay by having to use twice as much memory. And I couldn't do that for the low-level stuff. So that, I think, is important. And then templates, now we have concepts, which is also partly my handiwork, mostly together with Gabby Does Rays and others in the standards committee. But the push to generic programming and to compile time programming is something that I think is very good and important. A lot of the ideas for generic programming came from Alex Stefanov.
And then on the flip side of that, any regrets? Anything, if you were doing it again, you would do differently in C++?
This is a difficult one. I think all the major parts should be there, and they are reasonably good. And that includes exceptions, which I use extensively, and I think people should use more. On the other hand, with all of these years of experience, I don't think there's any major thing that I couldn't change a lot of details on to make better. I mean, I'm on record saying that I think I could build a language that could do what C++ did and better in 10% of the size by any measure. The problem is, of course, there's still these billion lines of code, so how would you get people to use that language? And yes.
Do you have any other non-C++ public projects that you're planning on doing or doing now that you're excited by?
No, and if I did, I probably wouldn't say so, because I always get quoted out of context.
Yeah, fair enough. That makes sense.
The same reason I don't do language comparisons. It's just too difficult to get ideas across without getting into some kind of language war.
Yeah.
I like languages in the plural.
We have a strong rule at Exercism that, well, discussing languages is a big part of what we do. Criticism of other languages is very much banned. And then the final, slightly tongue-in-cheek question maybe, but I think it's also serious, is do you ever get recognized in public? You're pretty famous as a name amongst developers, but do you ever get recognized in public?
It happens that I get recognized in the street or in the subway, in walking down the street in some random city somewhere. Barcelona, Reykjavik, it happens.
Nice. It's been quite a journey from trying to solve that little problem in Bell Labs to being recognized in the street.
Yeah, it's strange.
Thank you so much for your time. It's been a real privilege to talk to you. I know everyone's really grateful that's been watching as well. So yeah.